All right, so finishing up 6.3, this is our second part. Okay, so we've done difference of squares, and now we're moving right along. So we're going to be solving polynomials using what we call sum and difference of cubes. Okay, so little review here. The first things first, when we are factoring, we always check for a greatest common factor, a GCF. Great job. That goes on line 1. So this is basically our mental process as we are working through factoring problems. This is the first thing we think about, GCF. The second thing we look for is when we have a subtraction sign with two squares. What do we call that? What we just did. Difference of squares. Good. Okay. The next thing we look for is a trinomial, which is how many terms? 3. Does anybody remember how we factored a trinomial? X method. Cool. If there are 3 terms, that is what you try. Always the X method. What about 4 terms? This was the very first thing we learned. Start with the G. Starts with a G. Grouping. Remember where we group the first 2, group the second 2, take out their GCFs, okay? So those are what we've learned so far. Those very first 4 things. The next things we will be learning today are sum of cubes and difference of cubes. What does sum mean? What is a sum? Adding, right? So put a plus sign next to that so we are clear. Sum means addition. What does difference mean? Subtraction, right? So subtracting 2 different values. So sum of cubes and difference of cubes. Do we notice how on difference of squares, we could only do that with a subtraction sign, right? And we called it difference. So subtraction, difference, those mean the same thing, okay? But what we're going to find out is that with cubes, we can have both. We can have addition too. Okay, so we can't have addition with squares, but we can have it with cubes. And that's what we're going to talk about today. So, when using sum or difference of cubes, you must first make sure that you have a binomial. How many terms is in a binomial? 2. Okay, so basically you need 2 terms being added or subtracted, and they both have to be perfect cubes, meaning they can be cubed rooted. Okay? So, when we had difference of squares, we had to have a perfect square, right? Which meant whenever we typed in our calculator, for instance, if we typed in square root of 9, right? We got a whole number back out. So that meant that that was a perfect cube or a perfect square, right? Okay. So, when we have a cube root, when I type into my calculator the cube root symbol, which we're going to talk about here in a second, how to type that in, and then I type in a number, I've got to be able to get a whole number out. So let's do that real quick. I want you to grab that calculator. Everybody needs one. Turn it on. Clear. Okay. First things first, when you are typing these into a calculator, okay? With a square root, okay, it's a square root, which means that the index is what we call this, is 2, okay? But we never write the 2 on a square root just because we don't have to, okay? This symbol just indicates that it's a square root. But if we get any higher than a square root, we have to write the number right there, which is why on a cube root, you'll always see the number 3, because it's a cubed root, not a square root. You with me? Okay, so the calculators that we have here, these TI-30Xs, okay? If you have a different calculator from home, it might not work the same, but I'll show you how to work that here in a second after I do this. So on these TI calculators, we have a square root button just because that's the most common. What we don't have, though, is a cube root button. However, we do have a root button that's meant for roots that are higher than a square root. But we have to tell it what number our root is. Does that make sense? Okay, I know it's kind of funny. So we have to basically tell our calculator that this number right here is a 3 because we don't have a button for that, okay? So what you've got to type into your calculator, you first type the number 3, okay, because it's a cube root. Everybody do this with me. So you first type the number 3. Now you hit the second button. And then you're going to hit the little button that looks like a caret, okay? It's right above the x squared button. And what you should have now, you should have a 3 with an x right here, and then what looks like the square root symbol, okay? Now we type in our number. So now we type in 8 and hit enter, and what do we get back out? 2. So would that be a perfect cube? Uh-huh. Yep, it sure would. Okay? I want you to try another one. So clear it out. Now type 3. Hit second. Now hit the little caret thing so you get your symbol popped up. And now type in 27 and hit enter. 3. So would that be a perfect cube? Yeah. Okay, cool. One more. Type in 3. Second caret. 60. What do you get? 3 point something, right? A decimal. Okay, so this is not a perfect cube. It wouldn't work with this, okay? Not a perfect cube. You still get an answer, but it's not perfect. So are we good on how to type those in? We feel confident? Okay, cool. And just like whenever we had difference of squares, we had variables could be square rooted, right? Okay, so the same thing is going to happen with sum and difference of cubes as well. So what we're going to write here on these blanks, these are going to be our formulas, okay? And for a while, I'm going to give you these formulas. You will eventually have to memorize them, but for now, we're just going to practice with them, okay? So for a to the third plus b to the third, this is what the formula is for sum of cubes, because this is addition. We've got a plus b in parentheses, so first term plus second term, times first term squared minus the two terms multiplied together, so minus ab, plus b squared. Okay? So, a and b are the cubed roots of whatever numbers they give you. So, for instance, on this example, I need to cube root x to the third, and then I need to cube root 8. So this third root and this exponent of 3 are just going to cancel out, and my first term is just going to be x. And then for my second term, what did we say the cube root of 8 was? 2. Cool. So now I have a and I have b, and now I'm just plugging them into that formula. Okay, so everywhere where there is an a, I'm going to put x. Okay, and everywhere where there's a B, I'm going to put 2. Okay, for this middle term, it's A times B. So what is X times 2? Just 2X. Okay, and then what would 2 squared be for B squared? 4. And that's it. I don't have to do anything else after that. That's just going to be my answer. Okay. The next thing we have here is we have what we call difference of cubes. Okay, we see a subtraction sign between the a to the third and the b to the third, right? Okay, this is going to work very, very similar to sum of cubes, but there's going to be 2 differences. Okay, so if we notice with sum of cubes, this first set of parentheses we added because it was sum. Well, this is difference of cubes, so we are now going to be subtracting for those first 2. The a squared is going to stay, and so is the b squared at the end. But now instead of the a times b being negative, that's now going to be positive. So basically the differences that I need you to see here is that when we are adding from the get-go, we add in the beginning and we subtract in the middle of the second set. When we subtract, whoa, that's not a highlighter. When we subtract in the beginning, we subtract in the beginning and we add in the middle of the second. This seems like a lot, I know. It's a formula. We hate formulas. You hate math. It's okay. But it's going to get better. You don't agree? You don't think it's going to get better?
Probably not.
Probably not. You've already taken this class. You've already taken Algebra 2. So you've seen this before.
Yeah, somewhat. And I didn't.
You didn't like it back then?
I tried to get it added.
Okay. Well, it's back. It'll be a little easier this time. So now we've got to find A and B. So we take the cube root of the first term. What's the cubed root of x to the third? Just x. What did we say the cube root of 27 was? 3. Cool. And now we just plug these in. So we start. What is A? X minus, what's B? Close parenthesis. A squared is just going to be x squared. Now we're adding a times b, so x times 3 is 3x. And then we add b squared. What's b squared? 9. And we close the parentheses and we are done. Okay? Yeah. Say what?
I thought we were supposed to subtract in the second one.
Nope, That's whenever we have adding. Okay? So adding means you add first, subtract second. Subtraction means you subtract first, add second. It's gonna be okay. It makes no sense. We're gonna practice it. It'll make sense.
So do you have to put 3 to the second, like 3 squared? Is that how you get 9?
Yep, 3 squared is 9.
Wait, so when will we be taking a test on this?
We'll have a couple more class periods.
A
A couple.
weeks?
Okay, so here we go.
Couple business days.
Couple business days.
A lot of business.
Oh, for sure. Is there a business day or just a normal day?
Yeah.
Okay, here we go, guys. We're going to write up here at the top those formulas again. So we're going to start with sum of cubes. So I'm just going to put S to abbreviate. Or actually, let's do a plus sign. So we have a plus sign to begin with, okay? It is a plus b times a squared minus a times b plus b squared, and close parentheses. Now we have difference of cubes, so subtraction sign from the beginning. A minus b, close parentheses, a squared plus ab plus b squared. Okay. So, just like whenever we factor anything else, we always start by checking for a GCF. So I look at letter A. Do 8 and 64 have anything in common I could pull out? What do we think? 8 and 64. Is there any factors that I could pull out? 8. Good. So this is the same thing as 8 times what's going to be left? We didn't take out an x, so it's still going to be x to the third. And then what's 64 divided by 8?
8.
Plus 8. Good. Okay. So now we look at the inside. What do we notice this exponent is? Cubed, right? So we need to look. Can we have a difference or a sum of cubes here? Can x to the third, does that have a cube root? What is it?
1.
Yep, just 1x. Does 8 have a cubed root?
Yeah.
What is it? So b is 2. Is this a sum or a difference of cubes? Sum. So I need to go and I need to plug in these two values to this formula up top. So that's what I'm going to do. A plus b is just going to be what's a plus b going to be?
3.
What is a? What did we just say? Just a alone is x plus 2. Now a squared is going to be x squared. Subtraction sign, what's a times b? 2x. And then what is b squared? Plus 4.
I got that right.
Good. There's only one thing that I'm missing, okay? What about this 8?
Put it in front.
Put it in front. Good. Because we took out a GCF, it's got to be in the answer. Awesome. Okay. I want you to try letter B. You can do it. Okay, so looking at letter B, we first check, is there a GCF between 64x to the third and negative 1? No. Okay. But we notice we've got an exponent of 3, so we need to check, is this difference of cubes? And is it? I see some heads nodding. Why? The subtraction sign. And then do we have 2 perfect cubes? No? Yeah. We get whole numbers out when we cube root, okay? And what are those whole numbers going to be? 4 and
3.
a cube root of 1. Try it. Type that in your calculator. 3 second caret 1. Enter. And what do you get? Just 1. Okay? So the cube root of the first term. So cube root of 64 was 4. What about x to the third though? What's the cube root of that? Just x, right? So we do have to have an x there. Don't get rid of all your variables, or this won't work. Okay, are we ready to set this up now?
Yeah.
So which one am I plugging it into up here?
The red one.
The red one, the second one? Okay. So plug it in for me. What do we got?
We got 4x minus 1.
Cool. 4x squared. Okay, so when we do that, hold on, we've got to square this whole term. So 4x squared. What is 4x times 4x? 16x squared is what we're going to have right there. Okay, so make sure you square both the term and the variable, or the number and the variable. Okay, good. And now we do a plus or a minus sign. Plus. So a times b is going to be 4x, because 4x times 1 is 4x. And then plus b squared is going to be 1. And that is it. Okay. Questions on that? Not too bad? Okay. So now we're going to letter C. Okay. First things first, we check. Do 64x to the fourth and 8x have anything in common? 8, so I'm going to pull out an 8. And what's going to be left? Okay, did we pull out the biggest thing, we think? Was there anything else we could have pulled out? Because I'm going to be left with x to the fourth on the inside. Did they have an x too? Okay, so now we have 8 left. What else? X cubed, because we took an x out. Plus 8x divided by 8x.
There's just one.
There's 1. Yep.
No, just one.
Yep, the x is canceled, because x divided by x cancels. Okay. So, we've got this out front. We've got this inside. What is inside here? What do we recognize? Is that going to be a sum of cubes? Yeah. Sum of cubes. Cool. Tell me, what is my a value going to be? Okay, that's the first value. But to find a, we got to find the cube root of that. 2x. Okay, what about b? 1, thank you. Okay. We'll keep our GCF out front. Now we're going to perform sum of cubes. So we go back up, we look at our formula. we start with a plus b, which is going to be what? 2x plus 1. What comes next? 2x squared. So we got to square the number and the variable. What is 2x squared going to be? What's 2 squared? 4x squared, yep, because we square the number and the variable. That looks kind of ugly. I'm going to rewrite it. Yeah, what the heck? Okay. Next thing, minus 2x, because it's minus a times b, which is 2x. And then last but not least, plus 1, because 1 squared is 1. Okay, that is it. That's my answer. You don't have to simplify any further from there. Okay, letter D. We first check, do 48 and 243 have anything in common? They both have a y squared, okay. What about the numbers themselves? Okay, use a calculator and find the greatest common factor between 48 and 243. Three goes into both? Okay, is that the biggest that will go into both? Yep. Thank you. Okay, when we take out a 3y squared, what is going to be left? What is 48 divided by 3? 16. Anything else left? X squared. Okay, we'll keep our minus sign. What's 243 divided by 3? 81. And the y squareds cancel. Okay. All right. What do we see there? On the inside. The A and B thing? You think?
Oh, that's the answer?
No, it's not the answer. But I don't see a exponent of 3, do you?
Oh, no.
What do you see?
2.
An exponent of 2 on the inside? And a subtraction sign? So is this difference of cubes, or is it difference of squares? Do I have 2 perfect squares there?
Yeah.
16 and 81? Yeah, so this is going to be the other one. Okay, it is super important not to get these two things confused. Okay, so we will keep our GCF out front. What is the square root of 16x squared? 4. 4x, good, thank you. Don't forget about our variables. What about the square root of 81?
-9.
-9 and
+9.
+9. Good. Do we like those better than the?
Yes.
Yeah, those are a lot easier. So make sure when you spot them, you don't do more work than you have to. Okay, don't do the other way and get it wrong. Okay. Questions on that? No? Okay. If we can do letter E, successfully. That'll be the last one we do today. So I need everybody to give letter E a try. What do we look for first? A, what was that? Greatest common factor. So look for a greatest common factor on E. Pull that out if there is one, and then go ahead and simplify. Okay, so GCF between 1,000 m to the third and negative 125 n to the third. We start with just the numbers, 1,000 and 125. Anything that will go into both? 25, okay. And what's going to be left? Say what? 40. Were m to the third and n to the third, did they have anything in common? We forgot to check that. Yes or no? No, because they're not the same variable, right? Okay, cool. So 40m to the third is what's left, minus what? 5. N to the third. Good. Do 40 and 5 have anything else in common? 5. So we didn't pull out the greatest common factor. So we would have just got that problem wrong. So we need something bigger. What? Something bigger than 5, or 25, sorry. Try 125. What's 1,000 divided by 125? So 8. And then 125 divided by itself is 1. Are those going to be perfect cubes? Yeah. Okay, so we got to make sure we get the greatest common factor. Cool. What's A going to be? Cube root of 8 is? Cube root of 8m to the third. Come on, guys, we're almost done. 2 what? M and B. 1 n, right? Okay. It's difference of squares, so we'll go kind of fast. A minus B. Well, first we got to keep our GCF out front. A minus B is going to be 2m minus 1n. A squared, what is 2 squared? 4, and what's m squared? Just m squared. Multiply the 2 together. 2m times n. 2mn. And then what's b squared? 1 squared is just 1. N squared is n squared. Woo, we made that much harder than it needed to be. Okay, that is it. You have Delta math problems and then the rest of the 6.3 homework sheet. So I would start with the first 4 problems, especially if you did not do them, okay? And then finish that up. That is your homework.